just happened.
Oh my God!
Severe earthquake in Hawaii, USA. Strong earthquake in Los Angeles. Will it trigger a volcanic eruption? Today, we will use a scientific perspective to explore the complex truth behind meteorological events. According to the latest news from the Associated Press news website, on the morning of February 9th, a 5.7 magnitude earthquake occurred at Mauna Loa, the world's largest active volcano on the island of Hawaii in the United States. The U.S. Geological Survey initially reported a magnitude of 6.3, but later downgraded it, with the epicenter on the south side of Mauna Loa, 1.3 miles southwest of Pahala. Tremors were felt as far away as Honolulu, about 200 miles north of Oahu. The quake struck at 10:06 a.m. Hawaii time, causing very strong shaking in the town of Pahala, population 1,900, in the southern part of the island, according to the modified McCully magnitude definition. Vibrations of this magnitude can cause considerable damage to poorly constructed structures. At least 10 aftershocks of magnitude 2.5 and above were recorded within an hour and a half of the initial quake, about one every 10 minutes. Thank you for liking, leaving comments, subscribing and turning on the little bell. We will update every day. According to the Hawaiian Volcano Observatory, nearly all earthquakes in Hawaii occur on and around the Big Island. Friday's quake was caused by the weight of the Hawaiian Islands on the Earth's surface, a type of quake that occasionally strikes the islands. The earthquake did not affect Mauna Loa or the neighboring Kilauea volcano. Late in the afternoon, the U.S. Geological Survey reported a 4.6 magnitude earthquake near Malibu, California. The mayor of Los Angeles said the city's fire department was conducting a routine investigation to assess the damage. The epicenter was about 135 miles southeast of Kahului, Maui's largest town, and 215 miles from Honolulu. Other recent large earthquakes on or near the Big Island include a magnitude 6.2 earthquake off the south coast in 2021 and a magnitude 6.9 earthquake in 2018, which were shallower and felt more strongly. Kilauea volcano was erupting when the 2018 earthquake occurred. In recent years, earthquake events have occurred frequently around the world. Our channel once reported that an earthquake measuring 7.4 on the Richter scale occurred in the Noto area of Ishikawa Prefecture, Japan, at 4:06 p.m. local time on January 1, 2004. It was later raised to 7.6 on the magnitude scale. The earthquake was felt very strongly and the focal depth was even. Belongs to shallow layer. At that time, the earthquake was felt as far away as Tokyo. A video uploaded by a Disneyland visitor showed that after feeling the earthquake, the visitor immediately squatted on the ground to avoid danger. Passengers on the train were in the carriage and filmed the train shaking violently during the earthquake, and the electronic version of the ceiling on the train station platform shook to the point of falling apart. People went out to take shelter one after another, and some tourists who were skiing stayed in their cars or on the streets to avoid the disaster. After nightfall, a fire broke out in a row house in Wajima City, Ishikawa Prefecture. Although the area around the scene looked dark, flames and thick smoke could be seen coming out, and only orange flames could be seen in front of the eyes. Firefighters were unable to put out the fire immediately due to broken roads near the scene. Thank you for liking, leaving comments, subscribing and turning on the little bell. We will update every day. The authorities issued the highest level of tsunami warning, with tsunamis as high as 3 to 5 meters expected in Niigata, Toyama and Ishikawa prefectures, and called on people to evacuate. Videos posted by informants showed waves surging in the area, roads cracking, houses collapsing, and even fire alarms being triggered. Niigata, Toyama, Fukui, and Gifu prefectures also recorded earthquakes with a magnitude of 5, Osaka Prefecture with a magnitude of 4, and Tokyo with a magnitude of 3. Hokuriku Electric Power Company said 36,000 households were without power after the earthquake. The Tokaido Shinkansen announced that the sections from Tokyo to Odawara Station and Toyohashi to Shinkobi Station will be suspended until safety is confirmed. East Japan Railway Company also announced that the Tohoku Shinkansen, Jotsu Shinkansen, and Hokuriku Shinkansen will be suspended. There are many nuclear power plants in areas affected by the earthquake. Chief Cabinet Secretary Lin Fongjing held an emergency press conference at 5 p.m. to confirm that there are currently no abnormalities in the nuclear power plants. At around 4 p.m., the first wave of tsunami arrived in Noto, Ishikawa Prefecture, where a tsunami warning was issued, with an estimated height of 5 meters. A tsunami of 1 meter was measured at Noto Wajima Port in Ishikawa Prefecture, and a tsunami of 0.8 meters was measured in Toyama Prefecture. Globally, there are 3 main earthquake zones. The first is the Pacific Rim Seismic Belt. This nearly 40,000-kilometer seismic zone runs along the northwest and northeastern edges of the Pacific Ocean, passing through Eastern Asia, Western Central America, Western and Southern South America, and is driven by the collision and aggregation of plates around the Pacific Ocean. The boundary is active and contains huge flash flood energy and earthquake energy, making it the most frequent earthquake zone in the world. In Asia, the Japanese archipelago, especially Hokkaido, Tohoku, and the east coast of Honshu, has extremely frequent seismic activity. The background is that the Pacific Plate pushes the North American Plate to the west, forming multiple plate boundaries such as Omazaki, the Japan Trench, and the Tohoku Japan Back Arc Basin. In China and the United States, along the west coast of California, through Central America and the west side of the Andes, there are also earthquake-prone areas. This is caused by the expansion of the East Pacific Mid-Ocean Ridge and the mutual compression and collision of the Pacific Plate and the North and South American Plate. The landform is deeply cut along the coast and in the mountainous areas, with developed faults and steep terrain. This is followed by the Mediterranean Himalayan seismic zone. The seismic zone starts from Greece and Turkey in the eastern Mediterranean in the east, passes through the east side of the Iranian Plateau in the west, and extends to Pakistan and northwest India in southwest Asia, with a total length of about 12,000 kilometers. Tectonically, it is located at the junction of the Arabian Plate, the Indian Plate, and the Eurasian Plate. The Indian Plate and the Arabian Plate push northward, resulting in frequent crustal movements, accompanied by the uplift of the Tian Shan Mountains and the Central Asia region to the south. In Turkey, in the eastern Mediterranean and Asia Minor, the terrain is complex and faults intersect with basins. It is the most active area in this seismic zone. The high mountain and canyon areas on Iran's western and northern borders also have a higher risk of earthquakes. The southern foothills of the Himalayas are also active areas of this seismic zone. It is worth mentioning that there is also the East African Rift Valley earthquake zone. This seismic zone runs along the Great Rift Valley of Africa and almost runs through the entire East Africa. According to the theory of plate motion, the rift is the result of the eastward movement of the larger Somali Plate in East Africa. The Great African Rift Valley runs north-south, gradually descending the East African Plateau from west to east. The terrain is high in the northwest and low in the southeast, with clear landform zones. The northern section is dominated by imbricate fault block mountains and volcanoes, while the central and southern sections are dominated by large fault basins. Rich in geothermal resources, frequent volcanic activity, and strong tectonic movements, it is an earthquake-prone area in the world. On the other hand, Indonesia is also an area hardest hit by frequent earthquakes. On November 22nd, our channel tracked and reported on the strong deep-sea earthquake that occurred in eastern Indonesia. The magnitude 6.0 deep-sea earthquake occurred in eastern Indonesia at 10:48 a.m. The epicenter of the earthquake was located in the sea about 94 kilometers southwest of Tebelo City, North Maluku Province, with a focal depth of 116 kilometers. When the earthquake occurred, residents in Tebelo and surrounding areas felt strong shaking that lasted for nearly 30 seconds. Many people were frightened by the sudden incident, and tension and panic spread quickly. Some house items fell from heights, and glass windows made a shattering sound. Roads and buildings have cracks of varying degrees. A resident of Tebelo said that this was one of the strongest earthquakes he had ever experienced. His bed was shaking and he immediately ran outside in fear. After the earthquake, local residents were still nervous, and many people chose to leave indoors temporarily and go to outdoor squares for safety. At that time, the Meteorological Bureau predicted that a series of 4 to 5 magnitude aftershocks were likely to occur in the area, calling on residents to pay attention to safety, stay away from old houses, and pay close attention to tsunami warnings. The government sends staff to assess the disaster area and carry out relocation and rescue when necessary. This sudden earthquake had a huge impact on the lives of Tebelo residents. Furniture and items in many people's homes were thrown to the ground, and some houses had cracks and needed to be repaired. The power outage also greatly affected residents' lives, and the government urgently dispatched repair personnel to restore power. Cleaning up damaged roads is also a priority at the moment. Earthquakes are a natural disaster on the Earth, and their frequency and distribution are affected by geological tectonic movements. First of all, judging from historical data, there are about 500,000 perceptible earthquake events around the world every year, and there are about 1,000 to 1,500 destructive earthquakes that cause casualties and property losses. Although seismic activity is more frequent in some regions and time periods, in the long term, the frequency of earthquakes on the Earth as a whole has not increased significantly. Secondly, compared with history, earthquake monitoring equipment and networks are now more developed and more small earthquake events can be detected, which has led to a significant increase in the number of earthquake records in recent years. At the same time, the global population is growing rapidly, and living and working places are expanding to earthquake-prone areas, which has increased the risk of earthquake disasters and the number of victims. But this does not represent an overall change in the frequency of earthquakes themselves. Furthermore, there is considerable uncertainty about predictions of future earthquake trends. It is generally believed that the trend of plate motion has been basically stable in the past million years, and the overall occurrence pattern of earthquakes will not change drastically. However, in some areas, such as seismic belts such as Southern Asia and both sides of the Pacific, due to stress state adjustments, more frequent destructive earthquakes may occur in the next few decades. In addition, the long-term impact of climate change on the frequency of earthquakes also needs further study. From an urban planning perspective, taking some measures in advance can avoid or mitigate the impact of earthquake disasters. First of all, scientific site selection is very critical. Try to avoid geological hazards such as active faults, soft soil areas, and loose accumulation areas on mountains that are prone to landslides and foundation displacement. Secondly, functional areas should be arranged rationally, important buildings should be kept away from faults, and residential areas should be isolated from industrial areas to reduce the risk of secondary disasters. In addition, the disaster prevention system should be improved and the construction of earthquake damage prevention projects should be strengthened, such as setting up earthquake-resistant isolation foundations and building breakwaters. Secondly, in the design of buildings, anti-seismic structures are used to improve the overall lateral force resistance stiffness of the building. Common ones include reinforced concrete frame structures, shear wall structures, truss structures, etc., and buried diaphragm constraints are used to improve seismic performance. In addition, the fire prevention, smoke prevention, and chemical pollution prevention systems should be strengthened to reduce secondary disaster losses. Corresponding emergency systems should be set up on urban infrastructure, such as gas and water storage facilities, backup generator sets, 2 power supplies, etc., to ensure the normal operation of important systems after an earthquake. At the same time, with the close cooperation of planning departments and construction units, earthquake drills and assessments are carried out regularly. Combined with the geological hazard assessment system, we can master urban basic seismic data, dynamically assess earthquake damage risks, and take remedial measures in a timely manner. In addition, we will strengthen public education on earthquake prevention and disaster reduction knowledge and train residents in basic risk avoidance skills. When an earthquake occurs, fire and gas sources should be quickly cut off, people should be evacuated to predetermined shelters, and secondary disaster elimination work should be carried out under the guidance of professionals. Through comprehensive geological site selection, reasonable planning and design, and a complete disaster prevention management system, casualties and property losses in cities during earthquakes and secondary disasters can be effectively reduced. This requires close cooperation and long-term efforts from various departments of urban construction, planning, and management. Before an earthquake occurs and before the fault movement becomes violent, the stress in the formation rocks will gradually accumulate and produce anisotropic deformation on a microscopic level, which will cause some physical parameters to begin to change abnormally, becoming a precursor to some earthquakes. First, there are abnormalities in geoelectric and geomagnetic signals. Hours to days before an earthquake, the electrical conductivity, resistivity, and magnetic susceptibility of the surrounding rocks in the fault area will change, forming low-frequency electromagnetic radiation that enters the atmosphere and can be detected by specialized geoelectric and geomagnetic observation stations. Secondly, there are abnormal changes in groundwater levels and water quality. Due to changes in surrounding rock pressure, some groundwater levels will rise or fall significantly, and water quality will also change. In addition, increased soil gas emissions, such as increased radon gas content, will occur. This is due to the increase in deep fissures in the formation, which accelerates the migration of soil gas to the surface. What cannot be ignored is the abnormal ground deformation. On both sides of the seismogenic fault, there will be small-scale deformations that are far away from or close to each other. This can be detected with precision levels and strain gauges. It should be pointed out that many precursor signals decay rapidly with time and spatial distance, making it difficult to establish a stable correspondence. And different types of earthquakes and different faults have different precursor characteristics. This brings great difficulties to earthquake prediction. However, through comprehensive analysis of various types of precursors, it can still indicate the probability of regional strong earthquakes to a certain extent, which has important emergency preparedness significance. Thank you for liking, leaving a message, subscribing and turning on the little bell. We will update the latest news from around the world every day. Continue to use a scientific perspective to explore the complex truth behind meteorological events.